Good afternoon, everybody, and welcome to Zahn Academy. Today's webinar is Flexera Smile Ultra Plus and a lab's journey of implementation. And we have somebody very special joining us today. We have John Debri from Desktop Health. He is Director of Additive Manufacturing and Workflows for the Desktop Labs. And he is going to be giving you his opinion and his expertise and his experience working with Flexera Smile Ultra Plus and the Einsteins. So I'm going to turn this over to John as soon as I do some housekeeping with you guys. He will be doing a Q&A with us, and that's going to be at the very end of the presentation today. So please, if you have any questions, type them in to the bottom of your screen. And I will be launching some poll questions throughout that John has put together for us, so he can learn a little bit about his audience. I'm going to actually launch the first two now before we get started. And the first one is, are you currently 3D printing in your laboratory? So if you wouldn't mind just answering those for us, we'd really appreciate it. And I will send that information over to John. And our second, I won't even launch because everybody is 3D printing. We have 100% of our audience that is 3D printing currently in their laboratory. So I want to thank everybody for answering. And I'm going to turn this over to John.
Well, that's awesome. Well, Fran, thank you so much for having me today. And hello, everybody. As Fran mentioned, I'm John Debri, Director of Additive Manufacturing and Workflow for Desktop Health, and also the GM of the Digital Center. So the Digital Center is really kind of what it is laid out as. It's really a fully digital workflow center where we have all the intraoral scans coming in, and we have solely full digital workflows to file restoration and out to the customer. So it's been a great opportunity to look at some of the materials and then ultimately why we chose Smile Ultra Plus and have the opportunity to do this webinar with you all today. So let's get started here. So as an overview, we're going to start off talking about Smile Ultra Plus. We're going to talk about what it is, what you can do with it, and why we chose it. Next, we'll go into the ecosystem of Smile Ultra Plus, how it's a part of it, and how all of those connected pieces create a standardized, scalable solution any lab can incorporate into their production. The workflow section will go over the process of creating the restorations using Smile Ultra Plus that we have found to work best in our high volume lab setting. To finish up, we'll go over two of the most important topics, covering doctor and patient engagement, along with their feedback, and what a bottle of Smile Ultra Plus allows you to do. Okay, so I just wanted to start off with a little bit of an overview of what Smile Ultra Plus is. So as you can see, Desktop Health did have Flexera Smile previously. Smile Ultra Plus is really the evolution of that material, and it's a hybrid nanoceramic 3D printed resin that allows us to fabricate permanent and temporary crowns, bridges, veneers, and has really come to be our standard for printed denture teeth. And we also use that for our monolithic try-ins. It's available in shades A1 through A35, B1, and also the bleach shade. The shades pair well with the Base Ultra Plus shades listed that were just released 2 days ago. And this webinar is really geared towards Smile Ultra Plus, but we found that the integration with Base Ultra Plus has been so great, we wanted to incorporate some of that into this information as well. So this video is just kind of going over part of the reason why we chose Smile Ultra Plus. And really, all of the information here is good data. I've always been into data and an understanding of a deeper understanding of why we would choose a certain material over another. And this video is just kind of a little synopsis of all the information there that helped us come to that decision. So to highlight some of those things, digital dentures have always been a passion of mine. And Flexera Smile Ultra Plus combined with Base, and of course now Base Ultra Plus, it brings a new level of strength to printed dentures. I've seen a fair share of the early printed dentures shatter. And with these new materials, that to me is ancient history. This really allows us to move into the future, evolving what our restoration product mix look like in the laboratories and what we're able to offer with confidence to our customer base. When talking about fracture and strength, strength really isn't anything without stability. And that's why I wanted to include the information about the water absorption or the resistance to moisture. And with the testing that's been done there, I feel confident that these restorations are going to last a long time for the patient. And that's something that we've always kind of been hesitant, I feel, as a lot of lab groups to jump into, just because not knowing or feeling confident in the materials. These group of materials are really the first ones that I feel comfortable, and why we're really leading a charge into the 3D printing of more restorations, because they come with the strength and the aesthetics that we need in order to make those comparable products that our customers are looking for to the traditional processes. So again, in wanting to understand how Smile Ultra Plus compares to traditional denture teeth, but still within the CAD/CAM realm, we looked at how they compare to iVotion, which, being isostatically pressed, yields similar characteristics to traditional denture teeth. I feel it's a good benchmark all around to see Smile Ultra Plus compare favorably to the iVotion disc. So that way, we really feel confident that Smile Ultra Plus is the one to go to. And looking at traditional dentures, they've been around for decades. Everybody knows how they look, how they function, really what the longevity of those are. Everybody is very hesitant seeing the initial 3D printed materials, but due to the wear characteristics that we're seeing, we feel confident that this material is ready to be our denture tooth solution. And all the videos and all that is fun, but I don't get sold in looking at making decisions for a large laboratory on a graph or flashy promotional videos. So understanding more of the chemistry and the background is important to me. In looking at the Desktop Health Flexera Smile Ultra Plus, it has long chain polymerization, which provides the basis for the strength that we see in the testing. It also allows for ceramic fillers to be added, allowing for development of next generation materials. Desktop Health was born from eTech, and with development teams in Germany and in the US, they're showing to be leaders in the materials development and go-to market with those materials. We went with a partner who understands the chemistry and demands of the products in restoration in the oral environment. A lot of the other materials makers are coming out there that are getting into dental, like the Henkels, like the Loctite, BASF. All the other companies are trying to evolve their chemistry for products that work within the oral environment that are able to get CE and FDA clearance, Health Canada approval, all of those things where that is the core of what Desktop Health has been doing for decades now. So it's a way to feel confident in what they're delivering out to the public is ready for prime time. But as you guys know, a strong dental restoration without aesthetics, is like the first zirconia crowns available on the market. As new materials have been developed to enhance aesthetics, Flexera is a leader in strength and aesthetics with Smile Ultra Plus in the 3D printed space. The design characteristics allow for natural translucency to be visible with a monolithic printed denture. And as you can see there, as the restoration gets thinner towards the incisal edge, you do have that appearance of translucency there. It allows us to really, take a workflow and implement it in a fashion that is seamless, that is quick, and is scalable. And that's one of the big things that we don't do typically in our lab is spend the time to characterize. A lot of laboratories do like to spend a little bit of time in characterizing, and we do have a subset further in the presentation that will go over that process. But ideally, we are able to get a 3D printed part and make that our restoration with very minimal effort. And in talking about aesthetics, this shows you what really can be done with Flexera Smile Ultra Plus. You can utilize any of the light cure composites to really take it from a raw printed part that you're able to polish up into what you see on the screen there. Highly characterized with a lot of shade gradation in the restoration with that incisal translucency. Just a really good looking, in this instance, set of denture teeth. So it's really nice to be able to keep it as a very nice looking print out of the printer into something that you can then take up a few levels if you'd like to do that as well. So overall, when we look at the strength and aesthetics, we really want to understand as well, how does this actually hold up in the mouth? Tests are great, studies are great, but again, I'm a little bit harder to sell than that. I want to see the evidence, the facts out there in the marketplace of how well this material is holding up. And thanks to Dr. Wally Rennie, we got the images here of a Smile Ultra Plus crown that has been in vitro for 18 months. And in looking at that, that really is one of those aha moments that makes me feel like, okay, this is a great decision to go forward with because we're going to have that longevity. And that's one of those things when you have the strengths, the aesthetics, and the longevity, it makes for an ideal restoration for our customers and their patients. Okay, so next we're going to talk about the ecosystem. So Desktop Health really does have a full ecosystem in place. It starts with their live build DLP software. And many of you probably know this by the RP software name as it was previously known. So they've been updating that to live build DLP, which in looking at how we interface with live DLP, it will actually be enhanced much more going forward. So they're looking at some more of the automated nesting of indications, some of which we'll see in the video coming up. But it really is a great platform to start with nesting that is simplified the approach of nesting and really allows you to have as much control and interaction with that stage as you want to have. And again, at high volume labs, it's all about that scalability. And that's where we really want to try to limit how much manual aspects we send in not only the nesting side, but all the way down through that process. Next up, of course, we have the Einstein family of printers. So they have the Einstein and the Pro XL. In the Einstein and Pro XL, we've been able to really accomplish everything that we want to in terms of producing the varying resins in the Desktop Health portfolio to cover all of the requirements that we have as a large volume facility. Moving on, after you print those parts, you'll want to clean and then cure. So we will go through also the cleaning and curing of the parts as well. And I say parts restoration. To me, parts are what we print, and we still allow our technicians to take those and make those restorations. So that's how I kind of factor it in my head as I talk about parts and restorations going forward. So the Desktop Health ecosystem is really governed by carefully constructed information that's provided in the knowledge base. So everything it contained within the knowledge base, it really allows for great results right from the start. It contains the instructions for use, and those instructions for use really do provide an outline for successful implementation, along with the other helpful tips and tricks covering everything from the printers to materials, software, and accessories. And this is something that we really do frequent quite a bit in the laboratory. Not that materials change often, but the Desktop Health recently included the ability to cure Smile Ultra Plus with the Debri LED PCU. So having those different things become available to us have allowed us to then stay on top of really all the technology, utilizing all of our resources that we have available to us that we may have had from previous printer installations or things like that. So it's been a really great thing to stay up to date with the knowledge base and use that as our guide of how we can implement the Desktop Health ecosystem for success. So in talking more about the instructions for use, it's a common thing that you'll hear me talk about throughout this presentation. And it really is because Desktop Health has done such a good job with them. They are lengthy. Smile Ultra Plus, Flexera Base Ultra Plus are 12 pages. And you look at that and you almost have to set aside, a lunch period just to go through and read everything that's contained within the instructions for use. But they provide really the step-by-step success plan. And I highly recommend that you read and reread and have your staff read them to ensure success from the first time you drop a file into Live Build DLP to hit print. It really takes you step by step throughout the whole process. And that's one of those things where it takes all the guesswork out of what we're doing. Incorporating, especially if you look at a new printer or new materials, there's no really setup time. It's all contained within there, and you have a guide to go by. Really have that initial successful implementation and get everybody on board with this being the best route to go. So it's really been a good thing for us internally here because we're able to all be on the same page with how to set parts up, how to clean them, how to cure them. Again, everything within that IFU allows us to do so. One thing that I won't talk a lot about is on the design side. And the design side really is the most important part of a lot of what we do as a dental lab. And the reason why in doing so is that I want this presentation to be more so around how we've implemented the Desktop Health, Flexera Smile Ultra Plus, and that ecosystem into our laboratory work, not necessarily about how the design is there. So really, we actually do utilize both exocad and 3Shape along with AI partners for design internally. So we're really not too concerned in terms of getting a design in, as long as it does meet those requirements laid out within the IFUs. All right, so talking about Live Build DLP. Live Build DLP, again, is the nesting software for the Desktop Health platform. And it's something that we've really spent some time on internally, understanding how utilizing this software allows us to get the best results going forward. So I'll play this video, and this one really just goes over the full process that you can expect to set up those parts within the software. As we open up Live Build DLP, we start with our print setup menu. So on this one, we're going to select our printer first. On this one, we have an Einstein. that's called DTH printer. And we're going to select our Smile Ultra Plus. On here, we do have our shade selections, so we can make that selection there. And layer thickness. So layer thickness with Smile Ultra Plus, we do have build styles for both 50 micron layers and 100 micron layers. On the crown and bridge side, and actually on the denture side, I like to choose the 50 micron layers. It does take longer to print, but you do get that very smooth surface finish. And we know the accuracy is going to be 100% right where we want it to be. Really in looking at anything end use into the patient, especially on the crown and bridge side, much like with models that we produce, I like to be right at 50 micron layers with those, just to ensure the highest level of accuracy possible. So on that one, we're just going to select our 50 micron layer thickness there. And as you can see, it adds in the associated build style here. Okay, so we do have a few files. We have a couple crowns and a arch of denture teeth that we're going to set up. So we're just going to drag and drop those into the Live Build DLP software. So with the software, we do have the ability to utilize some of the autopilot functionality. So as you can see, we do have application settings for models, night guards, and restorations. So under restorations, we're just going to hit apply. And yep, we got crowns and bridges, and apply. So what this does, it'll go through and orient the parts and do some auto supports based off how things have been set up previously. So in looking at the parts, it's always good to review them. So what we're checking for is making sure the height of contour is supported, just to make sure that we know the parts are going to print successfully. As you notice that we do have quite a few supports on these parts, but the number of supports really does help the parts print successfully and are easy to remove. So I'm not concerned at all in seeing this amount of supports on the parts. I do see some areas where I would correct them. So on the arch of teeth, what we like to do is put them a little bit flatter and then also support kind of the outside border. So that allows for the mating surface where the teeth are going to sit into the denture base to be smooth, and then allow us to support and get proper accuracy out of the part with those different supports. So we're just going to select our denture teeth here. We're going to edit that one. So on this one, we're just going to leave what we have, and it's really easy to adjust these supports. When you hover over, it'll turn red. You can click on it to remove, and then you can go ahead and just place new supports around your denture teeth like that. And as we get further up, of course, the part turns to be more self-supporting. So we won't need as many supports as we move up due to the alignment or orientation of the part to the build platform. Again, we always want to make sure the height of contour is supported. With these being dentures, we know that as we go around that border, especially on the facial side, we're going to need the support in those areas. So we can remove the supports that are just kind of hanging out. And some of these you could definitely get away with keeping. We found that a little bit extra effort at this stage really does help on the finishing aspect of it. It is a little bit of a trade-off, but in taking it off of the finishing side, you're going to have a smoother part to then be able to finish and take a lot less time there. And really, you're able to retain the smoothness of the print, and that's a very important part of the overall process. There's just a lot of time spent between not only mating the parts together, if you don't have proper support. But you can also get then some potential sagging of the parts as well. So that's why we like to try to spend a little bit more time here to make sure we're really dialed in on our supports before we go ahead and process. Okay. So we're going to go ahead and apply those changes. As you can see, now we have our supports right around where we want them. There are a couple things here like the height of contour there. Looks like we'll have to add a support there, maybe there. So let's go ahead and adjust those a little bit. So let's select our part again. Add those in where they were missing. And really, these supports are very strong, so we really shouldn't have to worry too much about it in terms of them being longer and taller. They do a great job of supporting the weight of the part as it's being printed. Okay, so that looks pretty good there. Let's confirm that. And we're good to go. I do like to use the view buttons here. It does help a little bit as we're looking at the ability to make sure we're getting that height of contour. As you can see, the undercut angle visibility doesn't show you a very good height of contour. So that's where utilizing the view buttons to get a true view as the attachment points from the build platform. It really does help that way. So I do like that functionality. And also I'm looking at the job information page over there on the left side. As you can see, we do have a parts list. So you're able to then remove parts. Of course, you can always drag and drop to add more parts to the process as well. One thing that we really haven't spent a whole lot of time in looking at how you optimize, how you work within the software, is really looking at some of the other tools available to you. So some of the ones, changing the orientation, of course, if you wanted to lay those teeth down a little bit flatter, we have had very good success with those. And again, all depending on the software that the design was completed in. You may have some ovateness to the underside of your denture teeth that you may need to account for. Or you may have, a flatter surface, rounded surface like these are, where you really are able to support that border and then be good to go from there. So just a couple different options that we have in the software to really dial in how we get those objects supported properly. And then if we do want to adjust the supports again from here, we can go up, grab our supports, and then we can edit supports here as well. So it'll take us into that same menu as before. We do have a lot of options. One thing that we've played around with a little bit is that tip thickness setting. So 0.4 is very easy to remove from everything. And that's why we really stuck with that. These settings really are that great middle ground that we've found in terms of it giving reliable prints, but also easiest to remove. And as mentioned before, just easy support removal is becoming more and more important as we go forward in a scalable approach with Smile Ultra Plus. So those settings have really been good for us that way. Some things you can change also in looking at the base settings. You could add in some ID text to the base here, and I think this one actually does have it. So you can add in some information there. Really doesn't do much of anything right now. As you can see, it's the file names. And really, those are removed and thrown away so quickly. We don't really pay any attention to that whatsoever. So moving on, once we have our parts set up, supported, and ready to print, we just go ahead and select print over here. So job name, what we like to do, again, in having a few Einsteins, we're able to then say what printer it is, and then looking at the date, and then the shade, of course. So do plus D1. And then if it's a certain job of the day for that material, we'll start with A. So that way we know it's the first build of the day for that material, and in this case with Smile Ultra Plus, that specific shade as well. So at this point, we just send the job to the printer. And as you can see, it goes through. It shows us the layer by layer building aspect of the print. And it's pretty quick to process here. And the nice thing is you can have multiple windows of live build DLP open simultaneously. So while this is processing, you can be setting up another print on the same printer, but with a different shade of Smile Ultra Plus or other options like that. So a lot of great opportunities to be able to, really optimize your time in nesting. It's one of those kind of hidden time killers in the workflow. So really important that we're able to spend some time to dial this in, get that done quickly, and have the flexibility to go in and open up additional instances of the software. And once the job has finished being uploaded to the printer, we can then go ahead and do a couple things. We like to save the job. So to do that, we're just going to go up to File, Save As. So really with the jobs, we really hardly ever utilize them. They're really just to go back and take a look if we were a part failed or something along those lines. It's nice to have that job where you can go in and really go back and look, okay, was this supported properly? And really understanding where there may have been an issue. So that's really the best thing to keep the actual project file for. So we're just going to call this, typically go through with the job name that we created. On this one, I'm just going to put Ultra Plus B1, just being a test build. So we're just going to hit save here. And the next thing we like to do is print a job report. So we're going to go back up to our menu here and then print job report. So what this does is it saves it as a PDF that you can then go ahead and print. So in looking at that PDF, it's a very nicely laid out project plan with all of the STL file name information there. So everything's labeled here. It's very clear to see, easy to print. So if we do have an issue with a print, we can just circle the part that didn't print successfully, and then we're able to take that back in to identify quickly which file we need to then set up for reprint. Again, saving that job file allows us to go back, review the supports on it, and really that's where we find any of the issues kind of coming back to. There are some other things that we'll go over later in the presentation, but really looking at setting up and the supports on the parts, the orientation, making sure we're on the height of contour. All of those things are really the important things as we look at getting good quality parts out. And then from here, we're ready to go on to our next job. So as you can see, the nesting part is pretty simple. It's pretty quick. They are working on some more of the autopilot features to really enhance the nesting process as well for all indications. So looking forward to seeing all the new releases coming out subsequently for those new indications. Okay, so that was really just going through the LiveBuild DLP software platform. Just some of the helpful things that we found that have really help throughout time, just evaluate what we're doing and how we can optimize it. As you see with those denture teeth oriented that way, the print time is a little bit higher, but we're able to really stack those in as horseshoes and really get a lot on a build platform. So in looking at denture teeth as well, we're typically, catering to the larger volume shades. So we're able to get those on the build platform, and then we'll probably do one shade or one build of A35, A3 every once in a while, maybe a couple times a week. So that is something that just over time you get to see what your customer base, is really utilizing in terms of shades, and you're able to then plan your production and printing times around those. So that is one big indicator as well moving forward. Just to make sure that you have a good production flow built into it. So
As we open up live build DLP,
one more, sorry about that. So as we go into live build DLP, this was really one of the new releases, and it's one of the cool things, having dark mode. I know I personally use dark mode for every setting in Windows, and it's just nice to be able to see something without it being so bright all the time. So I just wanted to throw that in there, that dark mode, it is available with the newest version of live build DLP, and it really is nice to have that available. Just if you're going to be sitting in front of a computer all day, I really like, just that level of contrast there. Okay, so moving on to the Einstein family printer. We chose the Einstein with it having great accuracy. It allows for the printing of multiple materials in the Desktop Health resin family. It has a really good build platform size, especially when you consider the footprint that it's in. It is really the evolution of the E1 platform that utilized the secondary or external oxygen concentrator. So not having that, it really is a compact unit that you're able to really put into a lot of places, or what I really like it for is that you're able to put multiples right next to each other in a very small space, but still have good access to all of them and be able to really hot swap materials. And most of the time it's shades. So Smile Ultra Plus in doing denture teeth, that's really where the Einstein, I feel, is kind of come into really high volume production for us. It's really on those Smile Ultra Plus shades. We do also use it for some of the Flexera Base Ultra Plus in terms of looking at a dark mahogany shade, a light pink, just some of the different shades that you rarely get a request for. Due to that smaller resin tank size, you have less resin sitting there that you have to pour in, that you have to clean out then at the end as well, as opposed to the Pro XL. So it really is kind of that great unit for a lot of situations that allows you to get not only the accuracy you need, but the speed. And a lot of the speed too is from that heat that is generated with the closed loop printing, with those load cells that are monitoring the peeling forces. All of those things really combine together to make the Einstein a great solution for a lot of the indications that we look to utilize when processing Smile Ultra Plus. And then looking at the Pro XL, so we've had the Pro XL for a little over a year, close to a year and a half, and we were some of the initial beta testers of it. And early on, we were really looking at, okay, how can we optimize our model production? And that was really where the Einstein Pro XL came in. It allowed us to have a very large build platform size. As you can see, 9.8 inches by 5.5 inches. And then looking at that size, we're able to put quite a few models on. And in looking at model production, again, everybody's designs are different. So I can't really say what you would expect to see in terms of number of quads, number of full arch models, things like that. But I've been very impressed with the quantity of parts that you're able to put onto a Pro XL. And the accuracy there really is, from my testing, at the top end of any printer available at any price point. It's been super reliable, and it's been a great addition, especially because we've had to start putting them into production for denture bases. And if you would have asked me in the beginning of the year if we would be printing this many dentures, we were in that 1 to 2 dentures per week phase, and I would have said no. And looking overall at what we're trying to do, it is moving that direction of a printed denture now that we have these materials. But it was always something that was kind of on the back burner. So incorporating those for denture bases, but also Smile Guard. So the splint material has been a great addition as well. Printing those vertically, we can get upwards of 30 of those on a build platform. And the great thing is, again, less support, vertical, anterior 6, it's less finishing time. So anything that we can do to try to limit how much interaction we have with a part and taking that part and making it into a restoration is really the focus that we want to have in building our scalable printing solutions. So again, here are some of the timings for prints on the Einstein and the Pro XL. It just kind of goes a little bit more in depth of what you can expect to see. Some of these indications, of course, being very consistent across the board in terms of size of a arch of denture teeth, size of a night guard, denture bases. So all of those things are pretty consistent. So that way we can provide some in terms of quantity that you can get out of a build in the amount of time that we have set up there. Okay, so really just kind of to finalize, the Einstein family of printers has provided us with the speed, accuracy, and versatility we have needed to cover our production lab's needs. And in looking at the scalable impact of this, again, because we're utilizing Smile Ultra Plus and a lot more so on the denture side, we're able to utilize them regularly to print those denture teeth and have the ability to throw in, those separate temporaries or whatever else we may be printing in Smile Ultra Plus, including those monolithic denture tridents. Okay, so when I'm looking at the parts from an Einstein or a Pro XL, as mentioned before, really the smoothness of the part is something that you can feel. And it not only looks good, but also saves time when we're finishing those parts and really taking that part and making it into a restoration. And that's where, when we look at how we can optimize, seeing the quality right out of the printer was something that kind of caught our eye. It's something where all the printers are getting to that stage, but I really feel like the Desktop Health, Einstein, and Pro XL kind of led the charge in that regard, just of getting a good quality part out consistently and allowing us to really then take that, put our technician skill into it, and make that a restoration. And this quick video just shows the process of how you can take that monolithic denture and turn it into something more. Take it up those next few notches to really differentiate that from your standard monolithic trident. Okay, so now we talked about the printing family, we want to go to our cleaning solutions. So cleaning solutions, we do have the PWA 2000, and that is listed in all of the IFUs as well. It is a magnetic stir that agitates the IPA around the part. It really is a smaller chamber, but enough to fit a full build platform in. The challenge is that as we have scalable needs and requirements, it's kind of a big platform for what it is and the time it takes to move in and out. It does only have the one bath available. So we've actually migrated to the orbital shaker table. And the one we get is just the Onilab from Amazon. It's really inexpensive, and it really is customizable to not only RPM, but also time. So as you look through the IFUs and see this one needs to have a up to 5-minute wash initially, and then a 2-minute wash. We have a few of those lined up to where we can drop our first container on, run it for 4 minutes, and then clean it off, blow, dry them off, put them into that clean bath for those final 2 minutes before we do our final drying of the part at that time. So it's been a great addition in terms of the scalable approach with the Desktop Health ecosystem. Curing. So curing is one of those things that the IFUs really do cover in every way. We do have a lot of the AutoFlash G171 light cure units here. Great thing about those is their broad spectrum curing to really complete the polymerization of those 3D printed materials. Some of them are nitrogen compatible as well. And we do cure all our Flexera resins, Smile Ultra Plus and Base Ultra Plus, with nitrogen on. It is recommended to cure in an inert environment. We have cured both ways, and there's really no discernible difference that we can feel. So we've really just stuck to that, with that being the highest level of avoiding the environment of oxygen and getting that full cure. So we also have validated the Liquid Engineering Gearbox Plus, and now recently with the partnership to get Flexera Smile Ultra Plus on the carbon printers, we validated their Debri PCU LED as well. So now we're going to talk about workflows. and looking at the lab setup, the crown and bridge workflow, and dentures. So we'll go through this, as I feel like the lab setup side is something that printing companies haven't really been there to guide their customers in a lot of ways around how you can optimize a layout for 3D printing and what considerations you need, not only now, but again, with printing, it's all about that scalable approach. So how can you take this and make this scalable beyond what it is today with the thought of, okay, we're going to be adding 2 more Einsteins within 3 months once we get our Smile Ultra Plus print job up. Some of those situations where you have to have that greater understanding. And really, planning is the key to success. So I like to use Lucidchart to go through. As you can see on this one, I have our auto flashes, we had an oven for the E-tray material. But then with our Pro XL layouts, our Einsteins, our material location, an area that we'd be able to remove the parts off the build platform and then get those into the wash and cure as well. So a lot can be done on the initial side when looking at incorporating this into your workflow to really make sure that you have that scalable approach going forward. And then along with the other typical controls that we have for 3D printing, we wanted it to be in a well-ventilated space. We'll need to have temperature and humidity controls. And again, these are in laboratories. And I've been in laboratories for 20 years, so I understand how dust gets everywhere. Really making sure that you have a space that's easily kept clean and well segregated from any of those areas that create excessive dust. It's great to do that. So we have counter and storage space, IPA storage and reclamation. We do use a distiller here to reuse our IPA. Most of those you say are about 95 to 97% that you're able to reclaim. And that's really about where we are at with that as well. So a great option as you get to that scale to be able to reutilize your IPA that way. Again, waste removal, any of the hazardous waste that's get created, you gotta make sure we take care of that properly. But then also looking at where we have our nesting location, making sure that that's away from the printers slightly, enough to really keep it to where we're not, sitting in a room of the 3D printers all day. I've had some people say the resin kind of gets them and gives them a little headache. So it's always good to accommodate that within our lab setup. Again, some of the other things being file management. The next item, the curing grid visible. So that is an important step. Again, all of this is in the IFUs, but it's nice to have the little cheat sheets available and pasted up for everybody to see. So just wanted to run through that one really quick. Okay, so crown and bridge workflow. Again, crown and bridge workflow, we do print some parts in Smile Ultra Plus. Some temporaries, we've printed a few veneers in the material, and it really is kind of the lower side of adoption for us when you compare that to the removable side. And that's where, again, making sure with the IFUs that we're following the design, we get the design from a certified software, and then the processing. So it's nest, print, clean, cure, finish, cure. And that final cure is a really important one. Any adjustments that we do make to that external surface of the crown or internal, we want to make sure we're curing that surface again. So that's why we do have that listed on there as another cure. And as you can see over on the right side, more information from the IFUs talking about what indications are for Smile Ultra Plus. So again, we have our bridges, up to 6 units with no consecutive conics. In lieu of time, I'm going to skip over the next slide and then go right into denture workflow. So denture workflow, again, pretty much very similar to the crown and bridge side with the caveat of the data acquisition. And that's where this, to me, is the most important part of getting a scalable solution for removables. It's where we find a lot of the growth opportunities for our facility. And I feel in general in the industry that the laboratories doing digital dentures well can set themselves aside or apart from everybody else. And a lot of it has to do with how we get the data into our systems. So with the workflows of reference denture from iOS scanners, copy dentures, merging with Smile Ultra Plus, with Base Ultra Plus, it really is that culmination of everything that we'd want to see in terms of workflow, materials, at a price point to provide a restoration to our customers that they're going to love. And that's where the important part is there. So in looking overall, this was just a little video of assembling a denture. Really nothing outside of the normal here. We do like to use those little pipettes there just because it allows us to fill in a denture base, and by pouring Flexera base into that bottle, we're able to do quite a few dentures at one time without having to utilize a lot of micro brushes or things like that that can get costly after a while. So this has been a really nice scalable approach for us to assemble those dentures quickly. And we'll just kind of jump ahead. So again, when you're making those dentures, you just want to make sure that Smile Ultra Plus is seated very well into the denture base, because really that is our final check of how those are going to seat in the mouth, what the occlusion is going to be like. Early on, when we first started doing these dentures, we found some variation in the occlusal tables of the dentures, and really went to school on how we can make sure that that is not an issue anymore. So looking at how we support them and then how we assemble them are the two biggest things to key into to make sure you get those good, consistent results that we're all after. And in this video, Matt is just going around curing those teeth one after another to work around that full arch. So this was just a quick polishing video. I'm sorry, the cure video. So this is just the initial cure. With the assembled denture, we would do 4,000 flashes top and bottom. And that would be our first cure before we would then polish and then do that final 1,000 cure. And in between those, you do want to make sure that you do let the denture cool completely. Otherwise, what can happen is that you'll have a little bit of deformation on the border of the denture, and that will cause directly to fit issues there. So really important that you're able to let it cool, flip it over, and then process those remaining 4,000 flashes before you come to polishing. So with polishing, we like to use the pumice polish technique. So we use Razzle to do the initial pumice. And with that material, we're able to utilize a pressure similar to what we do for traditional analog dentures. So the nice thing is, even though it's a printed denture, we don't have to really completely add in a new workflow or process or feel for technicians. They're able to jump over and really get into the printed denture finishing as well. To finish those up, we do use the Valplast Mirror Shine, and that combination we found through many efforts of trial and error. Those work really well for us. But again, there are a lot of great options on the market. So it's not something that you have to adjust what you're doing, but just kind of play around and see what the material takes best in your experience. And that is the picture of our final denture there. So this one is actually the new Base Ultra Plus and the Smile Ultra Plus for the teeth. And the Base Ultra Plus being just released, we do have quite a bit of experience with it here already, and I absolutely love that material. It's been a great addition to the portfolio and really complements Smile Ultra Plus really well to make it a very strong and aesthetic denture. I did want to touch a little bit on the common issues and resolutions to those. So again, we talked about the design. That's really critical to make sure that we do have minimum thicknesses for the strength values that we talk about. The supporting of the parts, again, just making sure that everything is in alignment. Everything does go prints accurately. That is really the biggest issue that I see internally in looking at scale. It's just those little spots, making sure we can do that. So getting those supports on those height of contour or the bottom part of that part that's going to attach to the build platform are key. And really the next two kind of go in hand in terms of what does that part feel like when it's clean. or should be clean. So really just want to make sure that the IPA is clean that you're using. If you are using a distiller, make sure you do have a good gauge in terms of the overall alcohol percentage to make sure everything is functioning properly that way. Because really the cleanliness of the parts before cure is the biggest thing that can cause issues on the back end of it. It can either cause it to not cure all the way, or it can cause it to be tacky. So that's where the cleaning and drying are very big parts of that, along with not using an ultrasonic to clean those. A couple other ones there we don't really need to step on yet. Okay, so really the premise behind this whole webinar is Smile Ultra Plus and what we've been able to do with it. So we've been able to now provide predictable solutions on the printed denture side to our customers. And again, it's much like the data acquisition we talked about. It's about how you can educate and kind of forge that relationship deeper with your customer base about what's required to actually fabricate a good denture. It's not just intraoral scans. It's not just photos. It's a combination of both of those. It's a combination of taking a wash impression inside to make sure you get that consistent fit. It's about photos where the patient is straight up and looking directly at the camera, smiling. It's about a profile photo so you can see where the lip support is. All of those things, so that way if they do request those little changes that the reference denture workflow allows you to do, that it allows you to then do those quickly and efficiently. And that is really the biggest highlight for me in making this predictable for your customers. There's a lot of benefits that have been touted about digital dentures with being able to get a duplicate made quickly because of file storage. You can really deliver in less appointments due to that denture workflow. And really, we've cut out, I would say, 80% of our try-ins on the reference denture workflow, because those clinicians have seen those final dentures come in, and just the fit is so good that they don't even have to worry about a try-in. So that's been a huge time saver and huge cost savings for us at the lab. Another key point here is the customer communication documents, and those are really important because it is a printed denture. It's different than an acrylic denture, but what they do is they provide you the information that allows people to really understand those differences and tailor their use of the restoration to what those requirements are. So it's a great handout. That's actually on the next slide. But the last thing we really want to touch on here is patient feedback. In doing pilots with some of the groups and some of our customers, really the common themes that we have feedback from are they're lighter than acrylic. The fits are accurate, and we're really looking at, I would say 90%, 95% of doctors do not request post-dams in the designs. They're fully accepting of the denture with the wash impression in. It fits so good, so consistently that they don't have to worry about trying to add a post-dam in. Again, reference denture, they love the ability to correct previous denture design or function flaws. So a lot of times there's a cant in the occlusal plane. They'll want to lengthen the incisal ledge. They want to make those little changes that really can impact the patient and how they smile and their feeling about the restoration that they've received. And when you're dealing with somebody's smile like that, you really want to make sure that they feel 100% good about that denture and how they're going to feel projecting themselves out into their friends and family and everybody in their life. So that is good there. And then the patient and clinical engagement and feedback forms. So again, these are really important because it is a 3D printed denture. It is different than what your acrylic denture is. So these are just great documents that are hosted on the knowledge base that you can send to your doctors when you send the Flexera denture along. So that way they understand the difference and how to treat those, not only in their office, but for the patient as they wear those. Okay, and then I wanted to talk about really briefly what's in a bottle. So we talk about the material, we talk about how we can use it, but in buying a bottle of Flexera Smile Ultra Plus, what does that mean to me as a laboratory? Well, it means we can get quite a few units of crown and bridge. We can get quite a few arches of denture teeth. we can get, a good number of monolithic trines. But when you put all that together, it just means that you can buy the resin and not, be concerned that you're going to run into situations where you're running into an issue of the expiry date. Even if you don't use that material very much, because you're buying it in really the right size quantity, you can then factor that into your ordering to be able to have the right amount of resin on hand at all times. And especially with having Zahn as a partner, you're able to order that and receive that quickly. And these numbers are based off of me taking averages in the actual DLP live build software and adding 5% loss on top of that. So these are actual true numbers from a lab perspective. Okay. And with that, we're wrapping it up. Would you like to add Smile Ultra Plus to your lab workflow? Contact your Zahn rep today.
Thank you so much. That was really great. And I'm just going to launch this other poll and just let our attendees know where we're gonna be next, John. John is actually coming to Lab Day Chicago, and he'll be in the Zahn ballroom. So if anybody wants to come and visit with him, ask him some questions, by all means, drop in and see us at the Zahn Ballroom E and F at Chicago Lab Day coming up next week. It's coming so fast, so exciting. Also, our desktop health engineers will be there, Chris and Ash, who also did one of our webinars, and they'll be there to answer, some questions for you as well. You'll be able to see the entire desktop health system in the ballroom up close and personal with some samples, and you'll be able to see a really great lecture from Jack Morano, who's CDT for Absolute. He'll be there speaking on Flexera Smile Ultra Plus, and definitely on the base as well. If you have any questions, please type them into the bottom of your screen, and we'll be able to answer those questions for you today. Also, I want to let you know that Jack Morano will also be doing another webinar with us, and that's on February 28th, a Wednesday, 2 p.m. Also speaking about the desktop health system. So I want to thank everybody so much for joining us today. Please contact your Zahn representative if you have any other questions or would like to consider adding the desktop health system to your laboratory. And John, we want to thank you so much for your insight and expertise on the entire system.